In this video, we're going to talk a little bit about some of the theory about 3D assets and game engines and some topics to begin considering, thinking about, and understanding. There is a secondary video that goes into the topics that are in the later half of this presentation into much more detail with examples. And I would recommend that you look at that after this video. So, why do we care about how well our 3D assets work in a game engine? The reason is that 3D assets have a major effect on how well games run, and having like games makes headlines if you're working on a title and you don't, treat your 3D models correctly. You can, feel the wrath of people making fun of your game for not doing things the way that they're supposed to be doing. So for instance, this is from City Skylines 2, where it's having significant lag problems. And, excuse me, one of the reasons is because of how the 3D models are being treated in the game. So there are 4 areas that we're going to talk about today. The first one is going to be Tricount, then LODs. Then we're going to briefly talk about draw calls and batching, but I do have a separate video demoing draw calls and batching that you can watch. Tricount is very easy to understand. The first thing to keep in mind is that when you do import a 3D model into a game engine, every 3D object gets turned to tries. So even though when we're 3D modeling, we try to stick with quads as much as we can and maintain good edge flow when we're creating our assets, it's important to keep in mind that ultimately our game engines will turn these into tries. So when we're looking at polygon count for games, we are talking about the triangle count, not quad count or anything else like that. And each platform that you are working towards, and like where your game is going to be released to, will have a different optimal range where of how many tries you should try to keep visible at that time. Keep visible, but we shouldn't always try to keep at that limit. It's very easy to see try count in the Unity engine. Let's say that, actually, let me open up a better scene. Let me set this out real quick, sorry. Let's say that this is our scene here. We can see our try count over in game. Over here on the right, there's the stats button. If we click it on, we do get this stats window. If we hit play, as we play our game, we can see right here what our current visible try count is. So as we look around, we can see that try count changing as things are visible and render. In Unreal, it is a little bit different. The easiest way to do this is down here under the console command. You write stat engine, and it'll pop open a little window, and we can see static mesh tries. And it's rendering this giant landscape. That's why there's a whole bunch there. But this will give us our stats for our triangle count here. When we're done, we can just say stat engine stop, and it will stop displaying that. The next concept that I want to discuss with you, even though it is an advanced topic that at our stage we're not too concerned about, but you need to be aware exists, is the idea of LODs. LOD stands for level of detail. And the way that this works is that in your game engine, a 3D object will have multiple versions of a model and a texture at different levels of detail, hence the name level of detail. and your distance from the camera to the object determines which LOD is loaded. We've all probably experienced poor LOD transitions. This is sometimes called LOD popping, where you'll see a really low res version of a model, and the closer you get, it will almost instantly pop into a higher level of detail. This is meant to be a seamless transition, so if that occurs, it's a mistake, and there could be a variety of reasons why that occurs. But how do we actually make these? You can just create simplified versions of meshes and make smaller materials for larger objects. So for instance, if this was an object that we're holding in our hands in our game, we'd want to have it at a nice high 70K so that we can see the detail, but if it was further away from us, we don't need all 70K triangles. We would need it, we could keep it at a lower setting because on our screen it's only going to be, 10 pixels big. We don't need that many triangles. This is how games get away with being able to render very detailed objects up close that you can move away from. So if you remember from the first slide, this problem City Skylines was having is that these people, which you might need to be super close to them at some point and see this level of detail, their LODs are not set up correctly. So as you zoom out, more of the environment begins to load. Millions and millions of tries, possibly the level of detail is not turning on correctly. So we're having lag because it has too many triangles to render. As far as LODs in Unity go, unfortunately, as of the making of this video, there is no native tool that comes with Unity to self-create LODs. You'd have to create them by hand or purchase a plugin to create your LODs for you. But this is what an LOD'd object would look like in Unity, where you tell it, at what size of this, what size do you want the different LODs to pop in at, and this is all adjustable. And after a certain size, if it's way too small, it just calls it out. On the other hand, Unreal does have a built-in LOD creator, and in fact, it is a very well-created tool. It does a really great job at creating LODs when you load in your objects. So how do we do this? Let's say that I have this table object. I have a table object I'm going to load in, so put in this scene. So I'm going to first import in my table. And what I need to make sure when I'm importing this in is underneath Advanced, the Static Mesh LOD group, is I need to make sure that I choose it. It's possible, if you don't need LODs, select none. Not all your objects need LODs. If it does though, make sure that you are choosing kind of the correct category for this. And then when we import it in, it will create it for us. We can see this by double clicking on the object to go into the object view. And up here in the corner where it says LOD 0, that means this is LOD 0 that is loading. If we start to zoom away from it, there we go. LOD 1 is now loaded. And if we get really far, we can see LOD 2 is loaded. So we can watch those LODs load in and out, and we shouldn't visibly see it change ever. We can also adjust these. So it's possible that you need to tweak your LODs. They weren't created exactly the way that you wanted them to. So underneath LOD Picker, we could do a custom LOD where we can come into here and change the settings of our LODs to, change the triangle count of these if we do need them to be higher or lower per setting. The next topic I want to discuss is draw calls. Again, we're going to go over this a little bit, but I do have a whole nother video where we play with draw calls in Unity and we watch how different modeling and texturing mistakes can significantly impact your draw calls. So all a draw call is when your CPU asks your GPU to draw something on the screen. It can be any kind of art asset, so your UI, it could be a 3D model, it could be the material on the 3D model, it could be lighting on the 3D model, it could be a VFX, it could be post-processing, it could be fog, any kind of thing that draws to your screen requires a draw call. And this is kind of one of the large bottlenecks that we encounter in game development as far as games starting to get laggy, because it's very expensive. Materials do have a large impact on draw calls. So it's really important that we are managing how many materials are on our objects and that we are not importing in more than we need, and our objects have good modeling hygiene. We can use the Unity profiler to look at draw calls. This is one of the more fancier ways to do that I can show you real quick. We get to the Unity profiler underneath Window, Analysis Profiler, and it pops open another screen. And what we're looking for is this rendering. And the way that this works is you kind of have this open while you run your game. So I'm going to hit play, and it's going to record everything that's going on in our game as we play it. So we're going to look around, we're going to move around, and then when we stop playing, we can come underneath rendering and select a moment in time, and it'll tell us our draw calls. See that? So this is kind of the fancier way to do this, but honestly, unless you are working on a really larger project and you're trying to really narrow down some big memory bottlenecks, the profiler is probably going to be overkill for you. Instead, we can just look underneath the stats in our game right here underneath batches. For our purposes, batches, draw calls, it's the same thing. So we don't necessarily need to open up the profiler. We can look in the same spot right above where we saw the Tricount batches right here to watch our batches change as we play through. Adding objects, again, like I said, I have a whole nother video about this. Adding objects can greatly affect the batches, our draw calls. Adding materials raises our draw calls. Adding real-time lights with shadows, baking lights can also raise our draw calls, but also note that adding lights and stuff like that, it also raises our triangle count. Just because you have a certain triangle count in Maya doesn't translate to it being the same when you start working in game engines. For instance, since Unity is a forward renderer, when we start adding things like lighting and stuff like that, it's actually duplicating, it actually runs models so that we add to the triangle count. So we need to be very mindful of our models. So how can we kind of fix this? Like what are some things we can do? This is where the idea of batching comes in. Game developers use batching to group the rendering of similar objects to the same draw call. So instead of telling the GPU to draw, draw this wall, draw this wall, draw this wall, we can say, hey, those are kind of actually the same objects. Draw them all at once. So we don't have to have multiple draw calls for, all those walls. We can have one. The way that engines handle this is that the material has to be the same on those objects. If they're not the same, we can't group them together under a batch. How do we do this in Unity? It's pretty easy. All we do is if we have, objects that are the same. So like for instance, a lot of these models are going to have the same material. So like this has wall 1, this has wall 1, or this one has wall 1 and wall 3. Let me see. Oh, these are a good example. This has wall 3, and wall 3. How do we make them batch together? All we need to make sure that we do is set our objects up here to batching static. If we set these to batching static, the game engine will know that we want it to do a single draw call on those objects. This only works if it does have the same material on it. So this has the same wall 03 material on it. So these should batch together fine. We can't see them batch, in this window. We actually have to hit play to watch them batch together. So if we look over at them, we can see batch is 34, but saved by batching, it says 8. So we saved 8 draw calls by setting those to static. The Unreal Engine kind of does it automatically. Like we don't really have to do much as long as we keep those materials the same. But we do need to tell Unity that we want to batch them. So, make sure that we are using the same materials. We don't have any other weird materials assigned to them because then it's going to run into problems, and we can kind of work on that batching. Again, I have a whole nother video about draw calls that I recommend that you watch after this video that goes into a lot more detail about how different things affect the game engine.